Alright, let's go ahead and get started. We're going to talk about atomic structure, specifically subatomic particles. To begin, let's define the atom. The smallest division of an element that has all the properties of that element is what we call an atom. So if you consider the gold that we have here, if you were to cut this gold and then cut it again and cut it again and continue cutting it into pieces as small as you can possibly get, what you would be left with in its tiniest form would be one individual atom of that gold. Well, we've actually discovered that every other element is made up of even smaller pieces than atoms. So atoms are made of 3 subatomic particles, we call them, and these are the same particles in all elements, just in different ratios, different numbers of these things. So these 3 particles are protons, neutrons, and electrons. So what we're going to do is first talk about the proton. Now the proton, we've determined, it has a positive plus 1, a positive charge. Okay, so protons have a positive charge. Electrons have a negative charge, so the relative charge there is negative 1. So for every proton, you have an opposite charge of an electron. A neutron has a neutral or a 0 electrical charge. So some important things to note here. First, if you consider like a magnet, the positive side of a magnet is attracted to the negative side. Okay, so opposite charges attract. Similar charges repel each other. So 2 protons would push away from each other. 2 electrons push away from each other. Now, the symbol notation we have to be familiar with as well. The symbol form of a proton is P with a superscript of plus. Electron is E with a superscript of minus, and a neutron is N superscript 0. Okay, so you'll notice the superscripts indicate the charge on that subatomic particle. Now another thing to bear in mind is the location of these things. So if you have that atom, that single gold atom, okay, so let's say this is our gold atom. If you see the outside of the atom, what you're actually going to be seeing is a shell made up of the very, very, very fast-moving outer electrons. What you don't see is on the inside, you have this very, very, very small central part called the nucleus. Okay, the nucleus is where we have our proton. Okay, so the location of the protons are found in the nucleus, as well as the neutron. So that is also found in the nucleus. So the nucleus, location of protons and neutrons, a positively charged center of the atom. That is our nucleus. Outside the nucleus, again, the thing that is flying around at very, very fast speeds around that nucleus is known as the electron, and it's found in what we call the electron cloud. Okay, so this outer area outside the nucleus is what we call the electron cloud, and that's all of this space all throughout there. So a few things to bear in mind. We have the actual mass of a proton is 1.673 times 10 to the negative 24 grams. So this is an incredibly, incredibly tiny number of grams. Another thing that we know, the mass of a neutron has been determined to be 1.675 times 10 to the negative 24. So if you compare these two numbers, you notice they're very, very similar to each other. So close, in fact, that we say the relative mass of a proton to a neutron is a 1-to-1 ratio. Okay, so we say that these are about the same number. The mass of an electron is 9.11 times 10 to the negative 28. And this is actually really important to focus on. That negative 28 means that even though it starts with a 9, that's a bigger number, the exponent is a much, much smaller. Negative 28 power is much less than the negative 24 power. So the ratio that we actually have here is for every 1 proton, the mass of an electron is 1/1840th of that mass. Okay, so almost 2,000 times smaller than a proton and a neutron. So the thing to be aware of is The nucleus is the very dense positive center. A very dense positive center, right? Which means it has a lot of mass, but it has very little volume, very little space. Most of the volume, okay, so most of the volume inside an atom is empty space. Just empty space, okay? So what I want you to do now is go ahead and pause this video, work out these practice problems, and then I will go over them. So first off, which two subatomic particles have nearly the same mass? That would be the proton and the neutron. Write the symbol for an electron. That is an E superscript of minus. What are the relative electrical charges for each subatomic particle? So electrons have a -1, protons have a +1, neutrons have a 0 charge. Rank the subatomic particles in increasing actual mass order. So increasing means we want low to high values. And the lowest, the smallest mass is our electron, followed by the proton, and very, very close. You know, they're approximately the same, but the neutron is slightly larger in mass than the proton. The positive center that contains most of the mass in an atom is known as the nucleus. And lastly, most of the volume of an atom is actually just empty space.